All right, so I guess we're at time. It is now 3 o'clock. It is time to talk about agentic AI-driven unit test generation that you can trust. Hi, I'm Paul. I'm working as a senior architect at a company called Diffblue, where we have this fantastic tool that generates unit tests in bulk for you. I've been on the floor for the past couple of days. It's nice to see a fair number of faces here that I recognize, a few that I don't. If I don't know you already, come down and have a chat. I'm more than happy to explain a lot of the detail behind what's going on here. So basically today I want to talk about the idea of AI tools and what use they are if they fail to meet your expectations as a developer. Basically around accuracy and consistency. Like, what's the point in these tools if they don't work? Before we get into that, I want to have a brief chat about agentic AI. Now, you might be wondering why I've got a picture of a Roomba up there. It's a really nice example of an embodied agentic AI system. There are 4 things that it can do that lead nicely into the properties of agents in AI. It can perceive the world. It can sit there and say, I'm in a room, the floor is carpeted, or I'm in a room and the floor is a lino or a tiled floor. It can also, and it keeps track of this so it knows what it has seen in the past. It has a list of actions it can do. It can move from one place to another. It can start the vacuum cleaner rolling and suck up some dirt. It can sit there and say, oh, I need to mop this area, and mops the floor. It has a set of goals that it wants to accomplish. It sits there and says, I want to cover as much floor space as I possibly can, picking up as much dirt as I can, cleaning the floor as best as I can. It also has a notion of what the environment is that it is in. So it's in a residential room. It's not going to be particularly good at cleaning up massive amounts of floor space and office blocks or industrial warehouses. It is designed for a particular purpose. It is designed to pick up dust from a residential room, cover as much floor space as it possibly can, and figure out where it is in the world. So the whole idea of this agentic AI relates back to an idea in a book called The Artificial Intelligence: A Modern Approach. This is by Peter Norvig, who's one of the AI founders in Google, back in 1995. He posited the idea that there are 4 things you need to do. These are the 4 things I listed out before. So we've got the perceptions, what it can perceive, what an agent can perceive about the world. In the case of the Roomba, it's going to perceive obstacles. It might see that there's some, I don't know, sofa in the way, or there's a dirty sock. It's going to see that it's going to perceive the floor surface that I mentioned before. It's going to pick up on the battery level that it has. It might not be able to accomplish the task because the battery level is too low. It's going to take too long to get there, whatever. It's going to have some sort of idea about the odometry, so how far it's traveled and in what direction. It's going to have some idea about where it is in the world. The actions it can take, I've already mentioned: the move, the mop, the vacuum. The goals: we want to maximize the coverage of the floor space. We want to avoid damaging furniture, the house, pets, children, dirty socks. And we want to remove as much dirt as possible from the room that you're in. And again, I mentioned the environment. We are talking about residential rooms. Some of the more sophisticated robots are able to build up maps of the area as it explores. So it's going to figure out that the sofa is placed in this position in the room, or that there is a table over there. So this leads us into this question about, why do we trust a tool like this? Why do we trust the Roomba to do what it's supposed to do? It basically boils down to 4 key principles. It's reliable. It's going to make that you can observe the effects of the robot doing its thing. It's going to sit there and you can say, yes, the floor is cleaner. It has traveled that part of the floor. We are good. It hasn't damaged any of the house, the furniture, the pets, the animals, children, or itself. Right? So it's ticked on those 2 goals. It's explainable. We can say, OK, great. You have a low battery. Means you can't cover that particular area. Fine. It's going to find its way back to its home base. It's going to recharge. It's going to carry on. If there's a dirty sock that's blocking its path, it's going to figure that out and tell you, I can't get there because there's some obstacle in the way. I can't reach that area behind the sofa. You need to move and clean up a little bit before we get there. Again, some of the more sophisticated robots require this network connection to be able to build up that map, store it somewhere. it can explain to you that it has lost that network connection. It's secure. It's not. It's being bounded physically by the room that it's in. It's not going to go away and try and drive down to the local supermarket and spend all your money in buying chocolate biscuits and whatnot. It's not going to try and open up doors and windows for burglars to come in and steal all your belongings. It's bounded by the problem. It can only do a certain amount of things. It can only travel along the floor, pick up dust, and mop the floors. The key point here as well is that it's unattended. I can hit the button, it can go off and do its thing, and it leaves me to hands-free to do some other task that's much more meaningful, much more enjoyable, like going and sitting out inside the sunshine and enjoying a beer. Right? Who wouldn't want to do that? It doesn't require me to sit there on my app to tell it, oh, you need to go over this part of the floor and move around, vacuum this bit, and then move over there and vacuum that bit, and so on like that. It is completely unattended. I can delegate the task to it, and I know that it is going to finish that task completely. Which brings us on to the point about collaboration and delegation. So Agentic AI allows me to delegate tasks to it 100% of the time. I don't have to sit there and cajole it and coach it to give me the right answer. Collaborative models, like you might be familiar with a lot of the other LLM tools, are much more sort of interactive. And they do have their place. Like, don't get me wrong, they are useful, they're fantastic, they're amazing at what they do, but they only get you a certain part of the way there. There are some cases where you actually need to have that 100% accuracy, 100% precision in order to be able to accomplish the task at hand. Right? So an example of this sort of thing might be in the creative process. You know, you're sort of sitting there going, I want to write a blog post. Give me some ideas about writing a blog post. I like there's a list of things here. Can you explain a little bit about this particular topic? Give me a few more examples or whatever it is. You know, give me a start for this sort of thing. That's the sort of thing that this assistant is really, really useful at doing. You know, because you have that human in the loop, there is this potential for the lower trust bounds. You don't need to trust that it's going to do the right thing all the time. You're going to be constantly sitting there observing the results and seeing what's going on and interacting with it in a more meaningful manner. Again, if you're using this blog post as an example, you're going to be reading the topics that come back and saying, yes, I can talk for an hour about agentic AI and trust. And because of that, you're allowed to, it can fix the output, you can fix your output at a lower cost. It's not like you're sort of bundled up and trying to do all this stuff in one fell swoop. You have that opportunity to adjust and adapt the model and the output as you go through. AI agents, like my robot vacuum cleaner, are useful when you don't need to have that interaction. You want to scale them to larger tasks, so, I mean, okay, sure, it probably takes me about 10 minutes to vacuum the floor, but, I mean, would you rather be inside vacuuming the floor or outside enjoying a beer in the sunshine? Yeah. When you scale that across to a large house, that's the sort of time it makes a lot of sense to do this sort of stuff. High trust required. I mean, okay, sure, the robot vacuum cleaner probably doesn't require an awful lot of trust, but there are times when this does actually matter. We'll get onto some of that in the more software engineering context shortly, but we'll talk about that there. And the output must be correct. So you don't want to have the vacuum cleaner continually sort of emptying the bucket in the middle of the lounge only to come around and try and vacuum up the next bit because it's figured out that the bucket is full. You need to have it correct. You need to be able to trust that it's going to do the right thing. So a lot of the time, you know, we were looking at some of the statistics around trust and LLM tooling. And this is from the Stack Overflow Developer Survey in 2024. A lot of people simply don't trust the LLM tooling, right? That's a very high percentage. That's 40% of developers highly trust. 30% of developers somewhat distrust and highly distrust. You know, that's a third of people. Right? What's going wrong here? Why do people not trust the results? Yeah. Or this is about the accuracy, yes. So then you sort of start to look at where this is going wrong. Like, why do people not want to trust the AI tooling at work? You know, 2/3 say they don't trust the output of the answer. So this is cases where people are trying to use LLMs to write code, write unit tests, write that sort of thing, and they just simply don't get the answer right. AI tools lack a lot of the context of the code base, right? So this is where you have some sort of like proprietary library that you're depending on that's core to your application. The LLM has not been trained on that stuff, on that code. It has no idea that a foo object even exists. They're just going to say, well, I've seen plenty of examples of this sort of code out in the wild. This is exactly what you want to see because I've seen this thousands of times before. Has no idea that you have a specific object that requires specific handling. There's a few other bits and pieces in here about like policies and training data and education and people using them. But the two that I want to draw attention to are the trust the output and the lack of context. Those are the two key things. So what does this lead to? So why do we care about this stuff? Ultimately, the AI tooling is designed to be a productivity aid. The whole point in deploying these tools to a company is to be able to get more bang for your buck, right? As a manager, I would want to sit there and know that my developers are going to be doing the best productive work that they possibly can. I want to automate as much of their toil as possible, right? So if you have a particular task, you might go away and do some manual work, and you're having to sit there and sort of trial and toil away at this task until you get the answer, until you send it off to your colleagues in a pull request, and they're going to go, yes, that looks good, or you missed this case over here. It's that sort of interactive thing, right? And that takes a certain amount of time. So if that's our baseline, that's what we're working with. AI assistants allow you to have that interactive model. So they're saying, you can sit there and say, help me come up with test cases for my code, or I need to write a function that left pads strings, right? You can have that interactive back and forth and say, oh, that's not quite right. I need you to handle this case or that case or whatever. And you keep on having that back and forth. And yes, it'll save you some time, but you're sitting there having to depend on the output of the tool. You're having to have that interactive model. I was at a demo earlier on, and it took, I think, about a second or 2 seconds or so to get some answer from an LLM machine. Do you really want to have to sit there and wait for 2 seconds just to get a response that you're going to have to rework when you could probably sit there for that amount of time and come up with your own solution? I don't know. Depends on the task, I guess. But when you're able to deploy an artificial intelligent agent where you can completely delegate the task to it, that allows you to have a massive gain in productivity, right? You tell the agent to go away and accomplish some task, you hit the go button, you go out and enjoy the sunshine with that beer. You can come back, you can attend to the task, and you can pick up and say, yes, what you've produced is exactly what I'm looking for. Brilliant. Let's go. This is particularly important when it comes to scalability, right? If you have thousands of developers across your organization, this ability with the agent allows you to scale this up massively. Because you can delegate, because you can trust what it's going to do, it allows you to deploy that widely and have confidence that it's going to do the right things. So what are the challenges for LLMs in unit testing? Basically boils down to these 4 problems, right? So the problem with LLMs is that they can be unreliable. Every single time you give it the same prompt, you're going to get a different answer, right? I see a few nods in the room. Has anybody Java developers here? I'm assuming most of you are Java developers. Lots of nods for that. How many of you have tried LLM tooling? Yeah, there's most of the people here. Yeah. How many times have you found that it is completely unreliable? That it's going to give you a very different answer each time you prompt it. Yeah. That's almost exactly the same set of hands coming back up. Right? It's not deterministic. And in a testing context, we need that stuff to be deterministic. We need to make sure that the behavior of your code is there. Right? It also has problems with external dependencies. So if it has never seen a library that you're depending on, it will have no idea how to interact with it. Right? Again, I see a few nods. People have experienced this problem before. Right? LLMs are also unexplainable. It can't tell you why it's giving you the answer. It just says, that's the answer that you're getting. I tried this sort of thing out. I said, complete the sentence. The cat sat on the. What do you think it came back with? Anyone want to have a guess? What would you say? You'd say mat, right? I'm assuming you'd say something like mat. The cat sat on the mat. It can't tell you why it came up with suitcase or sofa or windowsill. It just simply can't explain it. So for unit testing, we need that explainability in that. We need to say that we are covering this line of code because, or this test case exists because it covers this line of code. It's insecure, potentially. I'm sure that there are people who've come across adversarial prompting before. This is particularly problematic if you're exposing your AI tooling to third parties outside of your organization, but even internally, you could have some problems with data exposure. Right. Again, you have no idea where the data for the LLM has been trained. It could be trained on some other company's proprietary code, and there'll be licensing issues you have to worry about. Has that ever come across as a problem for anybody here? I see a few nods of hands. Yeah. And again, that's a legal risk you have to worry about. Part of the problem is that you're being forced to trust third parties. Right? Again, you have to trust that they're going to do the right thing with the data you're sending to them. And the major point for me is that it's attended. You have to sit there and wait for the answer. You have to cajole it, you have to coach it, you have to tell it that it's being silly and it needs to be better at doing its particular task. It needs to generate these tests better. It's not thinking of the right unit test cases. And I have to sit there and constantly rework the results. So again, how many people here have had problems where it's given syntactically wrong code? Right, there's a few numbers, yeah? How many people have come across problems where the third-party APIs are just completely wrong? It's just invoking the wrong method. Yeah, there's a number of these problems. So again, I think that the mistrust of LLMs sort of boils down to these 3 key points here, especially in a testing context. When you're talking about unpredictability, you're talking about, is the code valid? Does it give you sensible assertions? Is it explainable? Can you still have to deal with the hallucinations and the non-deterministic behavior, and it requires that constant supervision. So then, if we have this problem with LLMs in a testing context, I think we ought to sort of take a step back and say, okay, are LLMs the right tool for the job? In order to do that, we need to sort of take a step back and say, why do we test in the first place? What's the point of testing? And basically it boils down to these points here, right? The later you find problems, the more expensive it becomes to fix them. Right? So if you have a bug that reaches into production, there are a number of things that could occur. You could lose customers if it's one of these data breaches, privacy things. You could lose revenue if your application stops accepting web requests or orders. Right? It can damage your reputation. Right? How many times have you heard companies that have been pulled up for GDPR violations? Would you trust a company with the same name again? Probably not. And then it takes a moment or two to get back into the flow of figuring out what it is you were doing at the time you wrote the code in order to understand what it is that you need to do to fix it. So it takes time to get yourself out of whatever context you were in before, switching back into that context you were in when you wrote the code. It takes time and effort to understand that. So then, what are the challenges with testing that we can potentially solve with AI? Right? So the challenge with testing is that it requires development effort, right? I'm sure that everyone in this room here, all developers, I'm assuming? Yeah, there's a lot of nods. How many people actually write their own test cases, their test code? Most of the people, yeah? Anybody hand them over to a separate QA testing department? I know that that's another pattern that's seen around. Nope, okay, everybody here writes their own tests, brilliant. How much time do you spend testing? Is it sort of roughly 50-50 development time to testing, or is it 70-30 or 50-50? Yeah, something about that, yeah. 60-40, somewhere in there. 70-30, yeah. 80-20, 100-0. Yeah, it takes effort and time and money to do this stuff, right? As developers, we are expensive people to do tasks. If you can have something to take over that task, you can be doing something a bit more productive. Managers will love that, right? Part of the problem with the testing is it's difficult to outsource, right? There's a lot of contextual knowledge that you have about the problem domain that you're in that you need to keep in your head as you're writing the unit tests, right? I'm sure that a unit test for some web application, highly distributed system is very, very different to something like the tool that I work on with the with Diffblue and Cover, right? Two vastly different domains, very different sets of problems. We still need to do the unit testing. How many people here actually like writing unit tests? A lot fewer people, right? There's about 100 people in the room, I think, and it looked about 15, 20 people having their hands up. You know, I would count myself as one of those people that actually likes writing unit tests. You know, I'm maybe a bizarre person, but I kind of sit there and I quite enjoy saying, how clever can I be to beat myself from 5 minutes ago? Can I break this? Can I break this assumption? Yeah, but ultimately, I much prefer writing code. So again, part of the problem that I have with LLMs is it's taking away the enjoyment of the job. I like the coding stuff. So yeah, I would much rather be writing code and then tests and then attending meetings for the umpteenth time in the day to talk about some release that I don't really care too much about, to be honest. I'm sure my colleagues are going to be watching this back at some point in the future. This is recorded, so apologies to them. Ultimately, engineers are human, right? So to get the testing mantra done, we need to be disciplined. We need to be sitting there. We need to be understanding the context. We need to have all of this stuff in our head. I'm sure that it's very familiar that this rule of 7, you can only keep track of 7 things in your head at one point in time. So trying to keep track of what state you're in, what lines you're trying to test, what test cases you have, along with the context of your application, is really, really hard to do, especially if you're being interrupted by a meeting like stand-ups or releases or some QA meeting. It's really hard to keep that context going through. So all of these problems with doing manual testing are the sort of things that AI is really, really good at. So the problem that we're trying to solve here with AI is that we want to write accurate unit tests that reflect the behavior of the code that you're writing the test for. This is a much harder task than just general text generation, right? The reason why is I've alluded to this all the way along. I've been saying that it's hard because we need to keep track of the libraries that you're using, right? So if you're using some third-party AWS library, we need to know that that is a possible set of classes that can be passed into a method under test, right? We need to have some understanding of the language that we're using, right? We write tests for Java. A lot of the LLM tooling doesn't realize that it's Java that you're writing tests for. You can tell it, but it doesn't understand that there's a relationship between the instruction that you're writing in Java and the code that's being executed on the machine, right? It has no concept of that. And ultimately, all of this stuff is is most valuable when it's 100% autonomous. I can delegate this task to an agent, and it's just going to go away and do the stuff that it's going to do. That is a nice reminder for me to start the demo. So bear with me briefly. I will explain exactly what I'm doing in a minute, but I'm hoping minus. Right. With a bit of luck, that's going to go away and do its thing. I will do when we get to that. So what I'm doing at the moment is I've just started a command, and it has utterly failed. Hooray for live demos. 2 dashes. Thank you. Minus Maven. We'll let that kick off. Yes, good. OK, so I've simply just started a command in the background. We will come back to that in a minute. I'll explain what's going on. So I want to take a bit of time at the moment to describe what it is about the agent that we need to design in order to write unit tests. So remember that we had those 4 things. We had the perceptions, we had the actions, we had the goals, we had the environment. So what sort of perceptions would an agent need to be able to write tests? Anybody want to have a guess? Don't be afraid, I'm not going to bite. Much? No? It's got to be able to see your code, yes. Yes. Anything else that anybody has in mind? Reading the documentation? That's not a bad idea, yeah. Anyone else? The requirements? Yeah. That's a good one. So with Cover, what we do is we look at the method under test. We don't look at the documentation. We don't have any set of requirements. If you're getting into that sort of space with requirements, you're getting into like more formal verification methods and saying, does this implementation match with this specification, right? There are languages, there are tools that do that. We don't. So you're quite right with being able to look at the code. So we look at the method itself. So we look at the bytecode. We look at the method's inputs, the method outputs, any classes, fields and getters that we can see, the rest of your code base for factory methods. So be able to create instances of like pizzas from a pizza factory. What sort of actions might we want to perform? Output some tests. Yes. That's a very important one. Yeah. Report if you can't. Again, that is a very important one, and I love that you've brought that up. We will talk about that in a minute. So cover all the branches. Yes, so that's one of the goals, right? So the goal of this agent is to improve the coverage. We want to get as much coverage as possible. So the actions it can do, it's going to sit there and say, hey, I've got this idea for a test. Can you run this through your method? So one of the actions is to propose a test case. We want to observe the results. And we want to run some code. The environment is the last one. So what sort of things might you want in the environment? What sort of things would the agent need? Sorry? The setup, yeah. So things like the classes and packages in the environment. The build system that you're using, right? That's going to inform a lot of information about the environment. It's going to give you the class path if you're in Java. It's going to give you the compliance levels, like whether it's Java 11, 8, 11, 17, 21, et cetera, et cetera, et cetera. Any of the dependencies, right? So with all of this in mind, what we do at Diffblue is we have this loop, this reinforcement learning loop. So at the left-hand side, we start with sort of this idea of predicting a test. Give me a test case that I want to run through. We then say, OK, let's write a test case for that. We run that test case through your application, observe the results, and then evaluate the effectiveness. Now, this effectiveness could be things like, it's based around coverage. So we're sitting there and saying, does this test improve the coverage over the previous ones? If you're starting out with an initial empty set, of course it's going to improve the coverage. If you're starting out with an existing set of test cases, it might be getting into the case where it's like really, really hard to get that one last if statement, but it'll try as best as it can. It tries this thousands and thousands and thousands of times per method in a second. From that, it feeds that information back into that prediction step, and then that's used to feed back through this whole loop. This is reinforcement learning in a nutshell. You've actually all used reinforcement learning before, I'm sure. Like, how many people do you remember back in your primary school days of being given like times table tests, right? What's 2 times 2? 4. What's 2 times 3? 5. No, you've got that wrong. Next week you try again, and you get 2 times 3 is 6, and you got the 4 before. So yes, that's right. You are learning by reinforcing the things you're looking for, right? You try this, you evaluate, you propose, come back and feed that back into the life cycle. So that's what's going on behind the scenes. That's what's going on behind this whole presentation as we're going through. So I'm going to explain a little bit about Spring Pet Clinic. How many people in here have developed with Spring before? How many people are familiar with Pet Clinic? That's a fair good chunk. Basically, Pet Clinic is a sample application produced by Spring that illustrates various different features of the Spring platform. So you've got a model view controller style application. You've got various Spring features, as I mentioned. You've got profiles. You've got various caching things. You've got some aspect-oriented programming, et cetera, et cetera, et cetera. There's a link there for GitHub. You can download the Pet Clinic application that I'm using for this demo from that link there. So, when I get the right thing. What I have here, this is the Pet Clinic application. It is running in the background on my local machine. It is designed to mimic the behavior of a veterinary service, and so it allows you to find owners. You can search for owners. I think McTavish is in there. So you've got a Peter McTavish living at that address. He's got a George as his pet. It's a snake. We have also got the ability to look for various other people. I think Davis is also in there. Right. And here we're getting a couple of results. Right. So notice how before we had McTavish, when there was a single result, it sent you to that login, that single page result. When you got people like Davis, you've got 2 results in there in the list. Right? This is going to become important because I'm going to be using this as an example for the tests that we generate. So let's see if I can make this bigger. No, not that one. Can I make that bigger? View. Appearance. This is where increase font size in all editors. I wish I knew my shortcuts. Where's the person with the IntelliJ shortcuts? I think it's something like, I don't know. Is that big enough for people? More or less? I'll explain it as we go through. So we have, the whole functionality that I was explaining before was this, around this owner controller form here. I think I can probably even get away with moving that. So what I want you to do is, for those that can read it, and I apologize if you're at the back and can't, just take a few moments just to read the code there. You should be able to sort of identify the logic flows that I was demonstrating before, right? If you submit a single name, if you submit a name and there's only one person found, we should end up with this hitting this branch in here. If you have multiple names found, we'll end up hitting this branch in here, right? So far, so good. So the command that I ran before is this create command. So what has happened, while I've been explaining to you what's been going on, doing the more important productive thing, is it has gone away and discovered everything about this project that I could possibly want. It's figured out that we're running Java 17, we're using Maven as a build system, we've got JUnit Jupyter API in there, so it's JUnit 5. It's set up to compile the test under Java 17. Et cetera, et cetera, et cetera. It's figured out that there are a number of packages in there. So we've got pet clinic, we've got model owner system vet, matching exactly the same as what we have in our application. And it's gone away and gone through every method, every class in my application, and written a number of tests. So this is the command line interface that I'm demonstrating here. We also have an IntelliJ plugin that you can do exactly the same. You'll get exactly the same tests between the two. Absolutely no difference. So what do these tests actually look like? I can navigate to the test. Trying to do this across multiple things. Owner controller Diffblue tests. Right. So what we have here, I'm just going to minimize the window over here, is we have a number of tests. And we should see that, what was the one I was looking for? Find owner, find by ID, throw legalized argument exception. I think this is the one I want. No, init create form process. Init find form, process find form. All right, here we go. So what we have here is a test that Cover has created for us behind the scenes. You've seen me standing up here. Look, no hands. We have human readable data in there. We have a couple of owners. We have Jane Doe at the top and John Smith. We are creating a mock owner repository and returning those 2 owners in that mock. We're then building a request and expecting to get a particular response. And you'll see here that the owner list that we get back is the thing we get back in that mock in that response is exactly the list of owners that we expect to see. Right. If we have a look at the case where there's a single owner, you'll notice that the response that we get back is redirecting to that case where we have a single owner. So that's exactly the behavior of our application. That's exactly the same thing as what I demonstrated before when I was typing in McTavish. So this is the McTavish case. The one before was the Davis case. Yeah? Is everyone clear and happy with that? If that's not clear, and if you can't read that, come down to the booth, and I'm more than happy to let you peruse that to your heart's content. So then, where does that leave us? Oh, we had a gentleman here asking about mentioning about the reporting. So in this output here, you'll notice that there's a number of tests that are being created. That's all very well and good. We've seen the examples of that sort of stuff. You'll also see here that there are a number of cases where we haven't created tests. So things like trivial constructors. So if you're accepting if you have a constructor that has no arguments, we consider that a trivial constructor that's just going to be setting up some object with default values. There's little point in writing a test for that. We understand Spring Framework and say, you know what, this is a Spring Framework callback. There's no point in writing tests for that. We also have a main method. No point in writing tests for that. You can get an awful lot more information about exactly what we write tests for and what we don't when we look at cover reports. So this is our reporting tool. This integrates quite nicely with the CLI and the plugin and allows you to measure the coverage as you go through, and it allows you to see the improvements of coverage as we go through. So what I did here is I ran the tool twice, although it's now done it 3 times for some reason. So the first time I ran it, I didn't have any Diffblue tests whatsoever in my project. This is what we call manual coverage. So this is the coverage that someone has gone away and written manually. Then I ran the Diffblue tool across the code base, and now we have a slightly different picture about the coverage. Right? So that blue line at the very top, I'm not sure how well that's coming out. There's a small difference between these 2 blue lines here. Right? This is the difference between those test cases that Diffblue has generated by itself. This one here, this lower one, is the coverage produced by Diffblue tests and manual tests. And then this figure down here is the coverage that's produced just by the manual tests. Now, Spring Pet Clinic, as I'm sure most of you are aware, is actually fairly well covered. So this is not a particularly great demo for showing the coverage increases that you can get, but nevertheless, we've been able to see that there's been a little bit of a coverage increase in there. The main thing I wanted to show, though, is that you can organize your projects. Here, we've got Pet Clinic, and you can go and start to look at the reasons why particular things didn't generate coverage. Especially if you go to the coverage detail, that'll give you a bit more detail as to exactly what's going on here. So in the add pagination module, it's a private method, right? When we're generating tests, we could use reflection to bust open that privateness, but ultimately the developer has decided that it's private for a reason, so we don't really want to test that. We don't want to bust that open with reflection. So we'd say, you know what, it's completely untestable. We'll try and generate test coverage for it through other means, but we're not going to do that. Yeah. It gives you a whole pile of reason codes and output codes as to what's actually going on behind the scenes. There's also a fair number of pretty visualizations like that. So yes. So where does that leave us? So why was I able to stand up here and trust that the agent was going to go away and generate the tests for me? Right? I know that that's going to give me those same tests every single time I run Pet Clinic on that example. If those methods change underneath, it's going to give me something slightly different. It's explainable. We showed that with the cover reports tool. You can see that in the output logs. We can see that we generate a user log file that you can say inspect in a bit more detail. It's secure. So I'm just going to hold up my laptop. The only cable coming out of this is the HDMI cable. And I've been offline the entire time I've been doing this presentation. So it has not made any calls back home. It's all contained on my laptop. We generated tests for all of that case. It's completely unattended. And again, you've seen me up here. I've not been anywhere near the laptop. I've not had to cajole it. I've not had to guide it. I've not had to do any of that sort of stuff in order to get it to work. It's completely autonomous. It's completely unguided. And in essence, we delegated the task to it exactly the same way as we delegated the task of cleaning my lounge to the vacuum cleaner. We've delegated the task of writing unit tests for my Java application to the tool. Because of that, we are able to scale to massive organizations, right? So there are a few examples that I'm going to talk about briefly. There's 3 examples here. At Cisco, they've been using us on an application where they manages 200 million IoT devices. You know, it's catching unintentional behavior changes across 6 million lines of code, right? Let's let that sink in for a minute. 6 million lines of code, right? Talk to me after if you want to sort of have a bit more detail about how we're doing that, because it's actually quite interesting the way that we're doing that. I would love to give you more numbers than that, but I think that Cisco are a little bit hesitant to give us real data. So I think that they just tell us it's a precipitous drop in these unintentional behavior changes. That's the best that we can get out of them. At Goldman Sachs, we are able to help them refactor faster. So again, imagine that you have a 10-year-old Java application where your developers have up and left the company and there's nobody around to fix or maintain the application. You're responsible for it, right? It's working to some point, it's been deployed to production, it's probably sitting in some server in some back office that everyone's forgotten about that the machine even exists. You want to take that application, put it into the cloud, you want to modernize it, you want to update the latest Spring versions, you need to have that safety net in there, right? Are you really going to pay a team of people to sit there and write unit tests for that? Why not let AI do it if you can trust it, right? So at Goldman Sachs, they saw 268 developer days of unit tests written in 8 hours, right? How many people would you have to achieve the same goal there? How much money would that cost? At Raytheon, again, they're doing this app modernization thing here, and they want to take a large business-critical application, move it into the cloud. So we covered 500,000 lines of code in the first few weeks of their usage of it, which again is fairly impressive, right? They're a defense contractor. We have no idea what dependencies they have. We have no idea what internal libraries they have. It just worked. I just want to leave some time at the end for questions, but I want to leave with this parting thought here, right? All the way through this talk, I've been thinking about LLMs and sort of comparing us against them. And to a point, it is very tempting to do that. I do want to say that they do have their place. They are assistants. They're there to have that interactive model. We're here to do that complete autonomous unit test generation. And I have a feeling that a lot of people are sort of treating the LLMs as a hammer. They're trying to, and everything to them looks like a nail. They say, let's throw it at an LM and see what happens. Do you really want to paint a house with a hammer? Thank you. Does anybody have any questions? While I'm answering questions, I do have some QR codes here. The links in the QR codes go to various points on our website. So we do have a free trial you can look at. GitLab and GitHub integrations, feel free to have a look at those. Anybody have any questions? I think the gentleman over there in the hat.
Yeah, hi. So I was just interested, when you were talking about code coverage, have you considered mutation testing, particularly because that could then indicate areas where you might want the agent to look at next to improve the tests?
That's a very good question. So two points to that. First is the way we test. So we do use mutation testing internally when we test our product. So we have a whole set of projects that we run our tool against as part of our natural CI process. So every time you make a PR, we run the projects and make sure the tests are the same. We do use mutation testing every release to sort of measure the test strength that we're producing, and we track that as one of our product metrics. The other point is that during our POV process, we do get customers, if they're interested and want to sort of have that proof point, to run tools like PyTest to do that mutation testing. And I believe that they're fairly happy with that. Yes, they're fairly happy with that. I've got a colleague down the back who's providing me these answers. Good. Did that answer the question?
Well, I was more interested in the process that the agent takes.
Right,
say,
okay.
Yeah.
Yeah. So in terms of the processing of the agent, the agent's reinforcement learning loop, it's very tricky to do that quickly, right? We're doing that. We've deliberately set a budget of about 1 second per method. We want to get as many iterations of that loop as possible. If we were to try and introduce Pi testing at that point, or the mutation testing, that'd be really, really expensive to do. It's an interesting idea. I'll love to chat with you afterwards if you want to discuss further if I'm not answering the question correctly or in the way that you want. Yeah.
Right. Thank you.
Yeah. Cool. I think there was a gentleman in the middle of towards the front there. Yes.
Right. So my question is about when you generate the tests, they never change. What happens when you change your code? Would those tests change and could?
Yes.
Okay, would those be reflected in the MR? So
Yes.
if somebody changes, okay.
Yeah.
That makes sense.
So the point I want to get across is that we're testing the behavior of the method. So if you change the behavior, right, I'm going to use an example, right? Suppose that I had a method that is greater than 5, right? Does exactly what it says on the tin. If the value that you're passing in is greater than 5, return true, if otherwise return false. If I accidentally change that value to 6, right? My unit test will pick that up. This tool will pick that up and say, okay, well, you've changed the value. My behavior's changed. I'm going to regenerate the test for that method. You will see it in your PR, your merge request. At which point the developer goes, hang on a minute, that doesn't look right. I shouldn't have changed that value. I've got a bug in my thing. It's particularly exposing when you have some sort of spooky action at a distance, right? Imagine that you've introduced a bug at this point, or you've done some changes in this point of the code, right? And you all of a sudden see tests changing over here at this point, like miles away from where you've made that change. Spooky action at a distance, right? If that shows up in your tests, great. It means you've probably caught a bug in your changes. And so you go, okay, well, I wasn't expecting to see changes over here. I need to go away and look at exactly what's going on between here and there, figure that out, fix the bug, away you go, before it gets into production. Yeah.
Great.
Yeah. I think that, we'll come forward and then we'll go, there's 2 at the back, and I think that's probably going to be it because I've got 3 minutes left.
If you have existing unit tests in your project, does Diffblue ignore the coverage that's already there?
We do have, I think we do take existing coverage into account. I think you can pass that in as a parameter, I think. I might be lying to you, I think that that's the case. If we don't, you'll get a set of Diffblue tests and manual tests, and the 2 shall meet in the middle. Yeah.
If the AI's only input is your code, how do you ensure that the assertions are according to what it is supposed to do and not what it really does?
Okay, that is a very, very good point. So when I say behavior of the code, we have to treat something as the ground truth, right? So there are 2 ways you can go about doing this. Either you trust that the developer has written the code correctly, or you have some machine-readable specification that says the method must behave in this particular way, right? This is the bounds of this behavior. We don't have that formal specification. Like, most people don't need it, to be perfectly frank. The only times you'll need it when you're dealing with safety critical systems like nuclear power plants or airplane software, possibly banks. I don't know. I don't work in banking. Someone from banking will probably correct me. But those are the really times when sort of that formal software verification stuff would be useful, like truly useful. You can employ something like that with your annotations in your contracts. Diffblue will pick up on things like nullable, not nullable, and use that to sort of guide what it does. But we assume that the developer has written the code correctly in the first place. It's a bit of a funky assumption, I know, but...
Does it prioritize the name of the method? Like if the method is greater than 5? And
it has no idea. I could call it foo, I could call it bar. If the logic is doing greater than 5, it'll write tests for greater than 5.
So the programmer's intention is not taken into account?
Not on a source code level, no. So we look at the bytecode, analyze the bytecode. Yeah, cool. I think there are a couple at the back. We've got a minute and a half. If I don't get to answering your question, please feel free to come down and find me at the booth.
I write unit tests mostly to prove the business requirements are met. And I don't trust the programmer who writes the code. Would this tool be still a fit for me?
Okay, if you don't trust the programmer to write the code, I assume you've got processes in place to make sure that the programmer isn't let loose on some safety critical systems, right? Right?
No, I mean, how would it verify the business requirement? Then I would...
So you would have some other. In our organization, we have these. Everybody goes through pull requests when they're submitting code, right? So there'll be something in there in the processes around this that say, okay, well, we're going to look at the code that the developer has produced, look at the testing to make sure that the tests cover exactly what needs to be covered, and away you go. So this, by using this testing as a litmus paper for incorrect behavior, that's kind of what I want to get across, is that it's a litmus test. It's not like this is according to some specification, right? It's an indicator that there might be something wrong.
Thank you.
Yeah. 10 seconds.
Thank you very much.
Oh, sorry.
Come find me after. We also have a whole pile of swag to give away, Apple AirPods being drawn tomorrow morning. Come and find us into the drawer. If your badges have been scanned, you're in the drawer automatically. Thank you.